Hey guys, we're going to continue with our discussion on rocks and minerals. So far we've been talking about Earth's crust, that outer shell of the Earth, which has major building blocks that we call minerals. When you have a collection of minerals combined together, we then refer to them as rocks. So what is a rock? One or more minerals bound together in Earth's crust. We have two major types of rocks: monomineralic. Mono means one, so these are rocks comprised of only one mineral. Limestone's a good example. Limestone contains the mineral calcite. You guys may recall that calcite bubbled when we put acid on it. For this reason, limestone dissolves very easily because of that dissolution of calcium carbonate. Quartzite is a mineral or a rock that contains just quartz. Now, most rocks, however, are actually polymineralic. Poly means many. So in other words, rocks have multiple minerals. And some of us may have granite countertops at home. We can visibly see the different colors of crystals or crystalline minerals. For example, you may see some of the white quartz or the pink feldspars and the black micas. So a lot of times rocks have a lot of minerals in common and can contain and share several minerals as other rocks do. How do we actually classify rocks? We have three broad categories, and they are classified based on how they formed, what was the environment like, and what set of processes in rock formation were taking place. There's three categories: igneous rocks, those that come from lava or magma; sedimentary rocks, typically which form underwater from the compaction and cementation of sediments; and metamorphic rocks, those that change form due to intense heat and or pressure. Today we're going to focus on the first variety, igneous rocks. Igneous rocks come from lava and or magma. So here's a great example of a volcanic eruption. This molten material will eventually cool, harden, and solidify to become an igneous rock, a volcanic rock. But why do we actually say magma versus lava? What is the difference? It's the same hot molten material. The only difference is its location. We call it magma when it's inside the earth, when it's below Earth's surface. We call it lava the moment it exits a volcano and it's found on Earth's surface. These differences result in differing cooling times. It's hotter down here, it's cooler up here. So that results in a different cooling rate, which results in different characteristics of the rock. As a result, we have intrusive rocks and extrusive. Intrusive come from the magma inside the earth. Notice not all of the magma inside the earth reaches Earth's surface at a volcano. Some of it collects below the ground and cools very slowly. This results in large crystals. The longer it takes to cool, harden, and crystallize, the bigger the crystals get. Here's an example of gabbro. Gabbro is an intrusive igneous rock. Notice you don't need a hand lens to actually see the crystals. Those crystals are easily seen because they're so large. That means this rock cooled deep within the earth. It's intrusive. Since it's so deep, it's very hot. It's under high pressure, meaning it takes a long time to cool. And if it takes a long time to cool and solidify, the crystals get bigger and bigger and bigger. So our intrusive igneous rocks are pretty easy to remember. We can remember the characteristics with this abbreviation for SLIM, L, I, M. So let's get ready to write. The S, what does that stand for? It means it cooled slowly. S for slow. Slow cooling. Please write that in. Since it cooled slowly, the L stands for large crystals. The longer it takes to cool, the larger the crystals get. I stands for intrusive, or inside the earth. Since it's inside the earth, we call the material, the molten material. M stands for magma. Extrusive are very different. This is where the magma reaches Earth's surface, exits through a volcanic eruption, and due to the reduction in temperature and pressure, it cools very quickly. Since it cools quickly, the crystals do not grow large, so it has fine crystals. Sometimes it cools so quickly that it develops a glassy texture. This is one of my favorite rocks. It's called obsidian. This lava exited the volcano and cooled instantly the moment it left the volcano. It had no time to develop a crystal structure. Instead, it has a glassy texture. For those of you who watch Game of Thrones, this is the rock that is used to kill dragons. It's a beautiful looking rock because of the rapid cooling and glassy texture. Another unique characteristic to extrusive rocks is a vesicular texture. Notice the holes in the pores. What these represent are gas bubbles. If you can imagine, the lava escaped the volcano, and the reduction in pressure allowed the gases in the lava to bubble up. And that bubbling gas burst out of the lava. As it cooled and solidified, it hardened those rounded gas pockets and solidified it into stone, creating what we call a vesicular texture, very common to extrusive rocks. All right, that's it for igneous, guys. We'll see you later.